Cool. First of all, we need to obtain the full path of the current working directory because we need to create a new entry in there. So, first of all, I'm going to get a the working directory, which is state.working directory. Then I am going to get the full path in which I'm going to create the new directory, which is wd dot. I'm going to create a small path method in the directory. Actually, I'm going to create that in the dir entry abstract class. I'm going to create a def path, which is a string, and this is going to be parent path plus directory separator plus name. Okay. This is pretty straightforward. And then back into Mkdir, wd.path is implemented. Now I'm going to need a couple of helper methods. So bear in mind, bear with me here as I am implementing this logic. First of all, I need to be able to navigate from the root folder into this full path as a string and obtain the object, that is the instance of the directory, where I actually need to create the new directory entry, or in this case, this new directory. So I would need to traverse this entire data structure starting from the root, and I would need to create a new entry in there and return a new root and set that into a new state. So the steps are going to be the following. I need to create I need to get hold of all the directories in the full path. That's step 1. Then 2, I need to update the new structure with the new directory entry. So create new directory entry in the working directory. Right? Third, I would need to update the whole directory structure starting from the root. 4, after the new directory structure has been established, that is when the folder structure, the immutable folder structure has been reconstructed, that is when I have a new structure, I'm going to get hold on the new working directory instance from the new directory structure. That is, I need to find new working directory instance given wd's full path in the new directory structure, because you remember the directory structure is immutable, and being immutable means I have to create it every single time I add or remove or change the contents of any of its components or constituents. This is one of the principles of functional programming, and if it seems in any way suboptimal to you, I totally understand, but bear with me here, and it will seem more natural to you as we go along, and as you get more familiar with this style of writing code. In fact, as we implement this particular assignment, we're actually going to waste a minimal amount of space. We are going to recreate the whole directory structure, that's true, but we are going to reuse basically all our existing instances where nothing will actually go to waste. Cool. So given that, we actually need to stick to this 4-step plan that we outlined here. So let's get down to it. Cool, so we actually need to stick to this plan. So all the directories in the full path is going to be a list of all the tokens in starting from the root and up until the working directory. So if I'm in /1/2/3/4, I need a list of 1, 2, 3, and 4 as a list of string, so that I can navigate this directory structure from the root, knowing all the names of the ancestor folders. So I'm going to say something like val all dirs in path. Let's call it like that. In path. I'm going to call a method on the working directory, which is I'm going to name this get all folders in all folder names, all folders. Let's just do it like that, in path. This is going to be a method that I'm going to implement in directory. So def get all folders in path, which is a list of string. Again, unimplemented. I'm going to leave many of these methods unimplemented, and then I'm going to implement them later, because by then the problem will already have been split into many digestible pieces, so to speak. So WD, so get all folders in path, this is going to be a list of string. That's all well and good. Good. Create a new directory entry in the working directory. So val new directory is going to be create directory. So that's going to be directory empty, and the parent path is going to be the working directory's path. So wd.path, and the name. See how easy it is now to create empty directories. Update the whole directory structure. This is going to be very, very interesting. We are going to obtain the new root of the new folder structure. And here we're going to create an auxiliary method, because the logic will probably be complex. So whenever you have, this is like a parentheses and a piece of advice, whenever you feel that the logic is going to be complicated, just create a stub for a method and make sure to implement it later. So I'm going to create a helper method just for this method do Mkdir. I'm going to call this update structure, and I'm going to pass in the old root, which is state.root. Then all I need is this guy, olders in path, because I need to navigate all the directories in path from the old root, create the new directory. So I need to pass in new dir as well. And I'm going to return a new root. Okay. And val new working directory is going to be probably navigate or find descendant or something like that. So I'm going to say new root dot find descendant. So I'm going to re-navigate the whole new directory structure from the old WD's path. So I'm going to give this guy as a parameter, because we've already done the work of splitting the directory names in the parent path. So I'm going to pass into find descendant, which I'm going to write in a second. And then finally, I'm going to create a new state from the new root and the new working directory. Let's create these methods. So update structure, I'm going to create a helper function here. So def update structure. I'm going to pass in a current directory, which is a directory. I'm going to pass in the path, which is the olders in path, which is a list of string. And I'm passing in the new entry, which is a dir entry. I'm going to make this a little bit more general, not just limited to directories, but to files as well, because Mkdir will behave very, very similarly to creating files. So I'm going to keep this as general as possible. And see how I named this parameter current directory? My intuition says that this update structure method is going to be pretty recursive because I'm going to navigate the whole path here. So try to, this is like a piece of advice, try to make value or variable names as general as possible and the types as general as possible as well. Cool. I'm going to leave this unimplemented for now. This will return a directory because its purpose is to return, gives the new root, right? So update structure is going to be the new root of the new directory structure, all right? So this will be unimplemented for now, and also I'm going to create this find descendant thing in directory. So def find descendant, and I'm going to put in a path which is in a list of string, and I'm going to return a directory entry. Okay, so find descendant will either return a file or a folder if this path can be found starting from this directory. Okay, so awesome. Find descendant. Oh, this will actually get me a directory. All right, let me go back and create a directory here. So this find descendant method is going to be restricted to directory because I actually need to return a state with the new root and the new working directory. Awesome, we have a lot of work in front of us, but we're taking step by step because we've split the problem into more manageable pieces. Before we start implementing them, I'm going to delete this little value that I've declared here because I've been a little bit overzealous in declaring it because we aren't actually using it anywhere. The WD path is just used here once, so that value didn't really make sense. Okay, let's get into the first thing, which is the get old folders in path thing, which we've left unimplemented until now. So the old folders in path is probably going to return a list of all the folders in this directory's path. So if the directory's path is, for example, /a/b/c/d, then this is going to return a list of A, B, C, and D. So we want that. Okay. So the way that we're going to do it is to get the hold of the current path of this directory, and then we're going to substring it with 1. That is, we're going to eliminate the first slash out of it. Then we're going to split by the directory separator, and we have A, B, C, D as an array. Then we need to turn it into a list. So I'm going to say to list. And that should give me all the tokens I want. So if I have /a/b/c/d, I'm going to get A, B, C, D. Good. Now that we have this implemented, we have step number 2 already implemented. So we have the new directory entry, which I'm waiting to insert into this directory structure here. So I need to implement the update structure method and the find descendant method after that. So let's move on to update structure, which is going to be, what have I done? I have scrolled a little bit. Which is going to be very interesting to implement. So this method is probably going to be something recursive because, let me show you what I mean. I'm drawing out this comment to draw a little picture in text. So for example, if I have a directory, let's say some directory, and inside we have folders A and B, and I'm trying to add a new directory which I'm going to name D. Then the result of this update structure method on sumdir is going to be a new sumdir with the same name and the same path, but it's its contents are going to be /a, /b, and the newly added /d. But this guy is going to be a totally new instance, and I'm going to reuse these old instances, which themselves might have some subfolders and subfiles. But I don't really care about that. I'm going to reuse these instances and add these this new entry here into a new directory with the same name and the same parent. Okay, so this is like the simple case. But if for example, I have a nested path, say /a/b/c, and inside I'm going to add a new folder. So I have /a and /b, and inside I have 2 folders, and then I'm going to add a new folder, new /e. Then what I have to do is I have to create a new B folder with the new contents /c/d reused and the /e newly added. And then, so let me draw this out. So I'm going to have a new /b /b with the parent /a, and its contents are going to be /c/d reused and the /e that I've just created. But this guy, the new /b, is going to be a new entry for the new guy /a. So I'm going to recreate /a as well. So this update structure method is going to be recursive in that it's going to recreate the entire folder structure, and it's going to return a new root at the end. Okay, so I'm going to pass in the root folder here originally, and then I'm going to return a new root. So hopefully this explanation makes sense. Take a little while, probably a minute or two, to get a sense of why we approached this method the way that we do. And once this is, I mean, it makes more sense to you, then feel free to continue. Otherwise, feel free to pause this video and make a little breakdown of why we chose this approach. Okay, so I'm going to delete this comment, and I'm going to start implementing update structure. So, like any recursive method, we're going to start with the finishing case, which is that this path, which is a list of string that I need to navigate in, is empty. That is, I'm adding this new entry exactly into the current directory. So if path is empty, then I'm going to add a new entry into the current directory. So current directory, I'm going to create a little method called add entry, and I'm going to create the new entry inside. This method is going to be a method in directory. So def add entry, new entry, which is going to be a directory entry. This is going to behave exactly the same for files and for folders, and it's going to return a new directory. I'm going to leave this unimplemented for now. The implementation is going to be pretty straightforward. But let me get back to Mkdir. Otherwise, I'm going to need to find the head of the path. That is, if I'm at /a and the final path is going to be, so current directory is /a, and let me put this as a multi-line comment so that it's clear. So if current directory is, okay, not scroll. So if current directory is /a and the path is /b or b, just the name of the folder, I need to get a hold of this directory so that I can then call update structure recursively on this directory and add a new entry inside this directory. So I'm in the case of /a/b with some content /c whatever, and I'm adding a new entry here. And I'm currently at /a, so I need to find the folder /b in /a's list of contents and get a hold of this directory instance, and then call update structure on that as well. Okay, so the approach is going to be like this. I'm going to declare a value called, let's say, old entry, which is the original /b in this example. So current directory. I'm going to create a little method called find entry with the path's head. So I'm going to find a direct child of this current directory with the name, in our little example, b. So let me create this method here, def find entry, and I'm going to pass in an entry name, which is a string, and this returns a dir entry. Okay, so find entry will return a file or folder with this entry name. Now that I've done that, if this old entry is not a directory, then I should error out. But given the fact that I'm already in a current working directory with a valid path already, I'm probably never going to get into the case where old entry is a file. So old entry will always be a directory, so there's no need for me to actually check. So I'm gonna say current directory, and then I'm gonna call in another utility method, which is going to replace this old entry with a new entry obtained by calling update structure recursively. So again, I'm going to create a helper method here. I'm going to say replace entry, and I'm going to pass in the old entry's name and the recursive call to update structure. So update structure with, in this case, with the new directory that I've just found. So old entry here, and then the path is going to shrink because I'm using path head already. So I'm going to pass in path tail and the same new entry that I'm finally going to add in my directory structure. So this replace entry method is going to be added to directory. So def replace entry, and I'm going to pass in an entry name, which is a string, and a new entry, which is going to be a directory entry, dir entry. And this is going to return a new directory because our entire directory class is going to be immutable, unimplemented as well. Let's delete this little semicolon because it annoys me. And yeah, we have a lot of helper methods, but let's go through this little structure here. So update structure works as follows. If the current path is empty, then I need to add this new entry into this current directory and return a new instance with the same current directory's path and name with the new entry as its content. So this edge case is pretty straightforward. Otherwise, I need to navigate to this path starting from the current directory. So first of all, I need to find the entry with the path's head, which is always going to be a directory. And then in that old entry, I'm going to replace the old entry's name with a new entry obtained by calling update structure recursively on this guy, on old entry, and with path tail because I haven't really finished navigating the path, and the new entry that I'm finally going to add in my directory structure. So if I'm to draw the little diagram again, if I have the directory structure like /a/b, and inside I have some contents and the new directory /e that I want to add. This is the new entry, and I'm starting from / from the root directory. Then look what happens. First of all, so update structure of root and blah 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 is going to do the following. Is path empty? Probably not, because the path is going to be A and B, and this new entry that I have /e that I've created beforehand. Now path is not empty, so old entry is going to be the /a with all of its contents. Then root is going to replace entry from the name A with /a's update structure. So update structure with the old entry /a. Path tail is going to be only the name B and the same new entry that I've created beforehand. Now update structure is going to say path is empty. No. Then old entry is going to be the /b, and then instead of root I'm going to have the current directory as /a. So /a replace entry the name B. So to the name B I'm now going to have another instance, another directory instance with update structure with the old entry /b. Path is going to be an empty list, and the new entry that I've created beforehand. Now the new call to update structure is going to say is path empty. In this case it will be, so /b is going to add new /e. So /b is going to add /e. Now I would like you to disregard my semi-pseudo Scala code here. This is just for explanation purposes. So this guy is going to be a new directory instance. So this guy is going to get passed here. Sorry. Let me do this. I'm going to copy this. Okay. And this guy is going to stay in this guy's place. And then when the function is called again, update structure root is going to get replaced with this guy. Whatever it means, right? Because Scala actually runs this method recursively, and this will finally be the new root. So this little explanation in the coding comments probably serve as a somewhat visual interpretation of what the code actually does. So hopefully it's clearer now why we chose update structure to be recursive the way that we actually wrote it. We have a little mistake that we need to fix, which is this guy, because old entry is a dir entry, is not a directory yet. So we're going to create a little method here in the dir entry to convert a dir entry to a file or a folder. So I'm going to create an as directory method, which is going to return a directory. And in directory, I'm going to implement this as directory, which returns this same instance. Now, for files, this method is going to throw an exception because files cannot be converted to directories or vice versa. Okay. Cool. So that should be it, but we need to call as directory here. Cool. So I think we're done. I'm going to leave this comment. Should I leave it? I'm going to delete this comment because we want the code to be a little cleaner. So update structure is done. We need to implement the utility methods in directory, and then we are done.